Datum reference, these are not MMC. This is maximum material boundary. So this is the tolerance zone shape. It will derive here that I have a cylindrical tolerance zone. If you have a square here, you can have a square tolerance zone. Tolerance zone size, this is the 0.5 here. And this is the tolerance size modifier, that is MMC. And this is the primary datum, 3 degree of freedom restricts, 2 degree, secondary datum, and 3 degree. Again, these are the mobility. So this is the mobility modifiers, and where you can go for the rocking, or you can say the shaking of the plane. This is not absolute the diameter change or the thickness change. So most of the people, they wrongly interpret this area and they add to the primary tolerance zone. So this, don't forget about this. If you have this type of interpretation, just today change it. And feature control frame decoding, now we'll try to understand. So quickly we'll go through this, and again our focus is this point. So this particular meaning here is the position. Next is the within a diameter of 0.5 mm, because this is phi. This is the MMC. Maximum material condition is allowed for this position, and relative to A, primary, where 3 degree of freedoms are restricted, related to B, where regardless of feature size, this is the RFS. What is regardless of feature size? If you are talking about a diameter of 27, if you are talking about a diameter of 5, if you are talking about a diameter of 12, we don't care. This is regardless of feature size. That means whenever you will see S, that is not respective to any dimension. That is overall package. So if you go for here also 0.5, this is regardless of feature size. That means only axis, because this is axis deviation, right? Opening of the axis. And the C is the maximum material boundary, not maximum material condition, MMC. This is MMB. This is MMB. And now let us decode it. So name the geometry control tool. The geometry control tool is a positioning tool, right? This is the positioning interference. Next, this is referring to this position. Next is the shape. The shape is a cylindrical tolerance zone. Next, size is 0.5 mm. Next, the modifier is maximum material modifier, and that is applied here. And the impact of the modifier is what? So in case of a hole, the size will be reduced. In case of a shaft, the size will be enlarged. So MMC here reduces the size, because less the size of the hole, it will weigh more. That means maximum material condition. And here the orientation and location for the basic dimension, where you can see the 25 and 40, that is managed, because this location is managed from here and here. That means the 25 is critical for us and 40 is critical for us. So you can see here there is no dimension. Most of the people, they apply tolerance here also. How can? Because here you have a variation, here you have a variation, and again you are giving tolerance. That is meaningless. So don't use that. So now you can see the tolerance, orientation and location of the basic dimension with respect to the datums A, B, C, which already I talked. So this is the datum reference. You can have datums here. You can have datum here. But if you keep the datum here, all the reference of this dimension can be taken as a basic, because from the origin only basic dimension can be taken. You cannot take a basic dimension now from here, because origin is not here. Wherever origin, from there you can take the basic dimension. Please note it. So this datum reference frame now can be interpreted in terms of primary and secondary, and you can simulate with respect to your gauge and inspection. So now I think you got the basic logic of GD&T, and let us do it and fill in the data. So what is the meaning of this? The position requires the bounded axis of the considered feature, because this positioning is with respect to this axis, and we lie within a tolerance cylindrical zone, that is 0.5, because of this particular note, and of a diameter 0.5, and at a MMC, and expanding by as much as 1 mm. This 0.5 and this 0.5 will be added, and it can expand. Expand is not with respect to axis. This diameter can also deviate, and axis can deviate, and collectively it can deviate 1. And you can see the departure of this particular condition because of the collective effect of the dimension tolerance and geometric tolerance for controlling the orientation, position, size, form control is now addressed. So what is the orientation of the basic dimension? So if you see the basic dimension 25 and 40 here, they are critical. So relative to datum reference, because we have keyed our coordinate system here, so